Permutations and combinations are widely used in solving problems of probability in genetic engineering, life sciences, business analysis, and many other fields. They're also extremely important because they are one of the fundamental building blocks of statistics. However, permutations and combinations are concepts that are consistently difficult for teachers to teach and students to understand. This is partially due to the way in which students are taught to look at permutation and combination problems. How are we usually taught to look at permutation and combination problems? We're usually given a couple of these cumbersome looking formulas and a couple of examples. Wow, these formulas are excessively complicated, plus we never really learn why these formulas work and where they come from. Simply remembering the formulas without understanding them is never a good practice, especially if we face a difficult problem or a not so typical problem. So today, we will ditch the formula. I will teach you a better way to solve permutation and combination problems. In this new approach, you don't need to remember any formulas. You will solve problems in a more logical process, and you'll be able to solve a wider range of problems.
The key to the new approach is to find the relationship between the number of permutations and the number of combinations. Here's a very simple example. How many different ways can we arrange two letters in a row? So let's first look at the first letter. So we can either have A as the first letter, which would give us AB, or we could have B as the first letter, which would give us BA. So there are two different ways, which makes two different permutations. However, both permutations belong to the same combination because we don't care about order when we're talking about combination. So AB is the same as BA in combination. So AB is the same as BA, which means there's one combination for every two permutations. In this scenario, the number of permutations is twice as many as the number of combinations. So let's represent P as the number of permutations and C as the number of combinations. And that would give us P is equal to 2C. Now let's look at another example. How many different ways can we arrange three letters in a row? So let's look at the first letter again. So for the first letter, we have three different choices, B, A, or C. So we have three different choices for the first letter. But once we use the first letter, we only have two choices left for the second letter. And then once we use the second letter, we only have one letter left for the last position. So that means we have 3 times 2 times 1, or 3 factorial ways in which we can arrange the three letters. So now I'm going to list out the 6 permutations. So we have ABC, ACB, BAC, BCA, CAB, and CBA. For these 6 permutations, how many combinations are there? Since we don't care about the position, all of the permutations are the same. For example, when order doesn't matter, ABC is the exact same as CBA. Therefore, all 6 permutations belong to one combination. Which means for the one combination, there's 6 different permutations. So in this scenario, the number of permutations is 6 times the amount of combinations. So if we use P to represent the number of permutations and C to represent the number of combinations, then P would be equal to 6C. But why do we examine the relationship between permutations and combinations? Why do we need this relationship to solve the permutation and combination problems? The truth is that it is actually very intuitive to understand permutation problems, and calculating the number of permutations is pretty straightforward. However, finding the number of combinations is not so easy. In our new approach, we will first find the number of permutations. Then we will find the relationship between permutations and combinations, then using the number of permutations and the relationship, we can then find the number of combinations. Let's look at this example. There are 11 players on a soccer team. How many different ways can a coach pick 3 defenders? In this question, the coach choosing Joe, Ken, and Rob is no different than the coach choosing Rob, Ken, and Joe. The order that the coach chooses the 3 defenders does not matter. Therefore, this is a combination problem. In our new approach, instead of solving the combination problem directly, we will pretend that the order that the coach chooses the defenders matters. The first player the coach picks will be the left defender. The second player that the coach picks will be the center defender. And the last player the coach picks will be the right defender. Now choosing Joe, Ken, and Rob is different than choosing Rob, Ken, and Joe. How many different ways can a coach pick 3 defenders now? Since the order does matter, this is a permutation problem. There are 11 players available when the coach picks the left defender. However, after choosing the left defender, there's only 10 players left to choose the center defender. And for the right defender, there's only 9 players left. So it's 11 times 10 times 9, or 990 different ways to choose the left defender, the center defender, and the right defender. So P is equal to 990. But that wasn't the question we were asked. We were asked to find the number of combinations, not the number of permutations. So what do we do now? We need to find the relationship between the number of combinations and the number of permutations. That's what I'm going to do over here. Let's examine one particular combination. The coach chooses Joe, Ken, and Rob. So if the coach chooses Joe, Ken, and Rob, how many permutations are there? Basically, you're asking me how many different ways can we order Joe, Ken, and Rob? There are 3 ways to place one of them at left defender. After we choose the left defender, though, there's only 2 players left for center defender. And the last player must be the right defender. So we have 3 times 2 times 1, or 3 factorial, or 6 different ways. Altogether, there are 6 different ways to arrange Joe, Ken, and Rob. This tells us that for each combination, there are 6 permutations. Thus, the number of permutations is 6 times as many as the number of combinations. We can represent this by P is equal to 6C. Since we have found P and have found the relationship between P and C, we can solve for C easily now. So C is equal to P divided by 6. And since we found P over here, we can just plug that in over here. So C is equal to 990 divided by 6, which is equal to 165. So there are 165 different ways that the coach can pick 3 defenders out of his 11-player team. Awesome! We have solved the problem in a logical and meaningful way, and we didn't use any formulas. Hopefully this approach has taught you a new way of thinking and has shed new light on permutation and combination problems. In the future, when you encounter a permutation and combination problem, you won't need to dig out your old textbook. You can simply solve it using your thinking skills.